Hello, this is a quadratic formula crash course. We typically learn quadratic formula in Algebra 1, but I know with the spring and remote learning, some students didn't get it. And I also recognize that some students just don't remember it. So this is a crash course. Now, the nice thing is we actually will be working with the quadratic formula in Algebra 2, expanding on the content from Algebra 1 later this year. So if you are worried about not necessarily remembering everything from Algebra 1, or you're worried because you didn't learn it, don't worry. We will get you there. And what we're going to do today, and honestly, it just ends up being the basics of solving. So the first thing, it's a formula. So just like if you take a formula for, Fahrenheit to Celsius, if you plug in the Fahrenheit, you get the Celsius type thing. It's just a formula. It's the same every single time. The formula solves the equation ax squared plus bx plus c equals 0. And I stress this because in order to determine what a, b, and c are, the equation must equal 0. So the first thing that you do is move all of the terms to one side of the equation and combine like terms. So for instance, if you are working with an equation with terms on each side, you first need to get everything to one side. The formula for the solution, which I will remind you, when we are dealing with quadratics, we always get two solutions. So the formula has to in some way give us two solutions. So I'm going to write the formula. So we have x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So the two solutions come from the plus and the minus. So it's the opposite of b plus whatever we get within the square root, and then the opposite of b minus what we get from this square root. And that's where your two solutions are coming from. The number underneath the radical, this b squared minus 4ac, we call that the discriminant. And it tells us a decent amount about the solutions if we just know that number. And so when I walk through a couple of examples, I'm going to give you some information about the discriminant, and we're actually going to come back at the very end and write that information down. But we're going to get started with just some solving. So number 1, we have 3x squared plus 7x equals 6. So I hope the first thing that you notice is this is not set equal to 0. And so I'm going to set it equal to 0. And I didn't write any directions down, but we are just solving each of these. And none of that worked. There we go. And so now I need to identify a, b, and c. Well, a is the number in front of x squared. So in this case, a is 3. B is the number in front of x. B is 7. And c is we call that the constant term. C is negative 6. Make sure you pull the sign with your a, b, or c value. And now we're going to plug each of those into the formula. So we have x equals the opposite of b, so negative 7 plus or minus the square root of b squared, which is 49. Be careful when you are squaring b. If you square a number, you never get a negative number. And sometimes students will type and obviously 7 in this case is positive, but pretending it was negative 7 for just a minute. If you hit negative 7 squared in your calculator and don't put parentheses accurately, it will give you negative 49. So you need, if you were going to square a negative number, I just chose B just so it doesn't get confusing, you would have to put parentheses around it so that it gives you the correct answer. So 49 minus 4 times A times C, all divided by 2A. So 2 times 3. So then I would figure out the discriminant. So I would do 49 minus 4 times 3 times negative 6, or multiply those. What is that? 6 times 3 is 18, 36, 72. So it's 49 plus 72. and we get 121. So then I have x equals -7 plus or minus the square root of 121 all over 6. And I hope right now you're noticing something. The square root of 121 is a nice, pretty integer. Square root of 121 is 11. So then we have our two solutions end up being -7 plus 11 over 6. What is that? 4 over 6, which is 2/3. And then -7 minus 11 all over 6. -18 divided by 6 is -3. So our solutions end up being 2/3 and -3. So I told you we're going to come back after the examples and write down what the discriminant told us. If the discriminant is a perfect square, we are always going to have, I'll come up here. So if it's a perfect square and it's positive, then we will have rational zeros. So those solutions we got, we can call zeros. If we have rational zeros, that also means the original equation was factorable. And so I chose this one on purpose because I knew it was actually factorable. I could have factored it and got the answers. But I wanted to show you what that looks like with the quadratic formula. In most situations, I would not have done the quadratic formula. I would have factored it. All right, number 2. Let's do 3x squared minus 6x equals x plus 1. So the first thing I'm going to do is set it equal to 0. So I'm going to subtract over the x and subtract over the 1. Now, if you subtracted it to the other side, that would be fine. The formula would still work. So this tells me that a is 3, b is -7, c is -1. And then I'm going to plug it in. So the opposite of b is +7 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So in this case, I have 49, and that ends up being 49 plus 12. So my discriminant ends up being 61. And there is not a perfect square that goes into 61, meaning there's nothing else I can do. I'm done. Those are my answers. So if it is just a non-perfect square as a discriminant that is positive, let's go back up to our list. So our second case was a positive non-perfect square. You just need to simplify and clean up. And you get 2, and we call those irrational numbers. They are decimals that don't end. I think I'm going to come over here. Let's see. All right, I think here should give me plenty of space. All right, let's do -1/2 x squared minus 5x minus 20 equals 0. This one's already set equal to 0 for us, which is great. So we don't have to rearrange it at all. I will tell you we could add everything over to make everything positive or divide by -1. So we don't have to deal with as many negatives, but it doesn't actually make a difference. So we have the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So 4 times Well, let's do -4 times -1/2 is 2 times -20 is -40. 25 minus 40, -15. And I hope you're noticing something very quickly. You cannot take the square root of a negative number. And what that tells us is that there are no real solutions. And the portion of Algebra 2 that talks about the quadratic formula, we are going to spend a whole lot of time talking about what this means. If we were talking about the function, if there is no real solution to the quadratic equation when it's set equal to 0, the relationship between the equation and the function would then be that there wouldn't be any x-intercepts, which I hope you can picture what a parabola would look like if there weren't x-intercepts. You have pretty much two options. You could have something above the x-axis or below the x-axis if you were to graph the related function. But we will talk a whole lot about that situation. If it pops up at this point, just all you have to know is that there's no real solution, and that's all. So if it is a negative number, there is no real solution. All right, so that is a crash course. It was enough information that I hope that you're able to do some questions. So go back and try the ones from homework on Monday. And if you are still struggling, Khan Academy has a ton of quadratic formula practice. That would be another way you can continue to practice as we move forward. But know that this topic is not, we're not done with it. We're going to keep building on it. I'm going to keep showing it in class, so it's going to keep coming up. I hope you are having a good day. Thank you.